In this video, we're going to take a look at the first area formula to find the area of a non-right triangle. Similar kind of proof to what we did for law of sines, so therefore we'll have sine in the situation. Just going to draw a quick axis. I don't really need the axis for this, but it's something I'm just going to add in. And that was supposed to be straight, but good enough. Okay, so given the following information, triangle ABC with angle A in standard position, and the fact that H is the height or the altitude from angle C, to side AB. We are going to prove the area of triangle ABC is 1/2 BC sine A. And then this formula is similar to law of cosines in that there's a couple different variations depending on the angle that you're given. So it has to be the angle with the other two sides, side angle side situation. We're going to go back and use sine again. So we're going to do sine of A is equal to H over B. Solve for the height. So B sine A is equal to H. And the goal here, just like what we did with law of sines, is to eliminate having to find the height. So we have a formula we can use for any triangle. So area is equal to 1/2 base times height. I'm going to write out the formula so that we're not using the letters B and H, since we want to actually replace those values. Now in this case, our base is C. So I'm going to do 1/2 times C, and the height is sine A. Or sorry, the height is B sine A, so times B sine A. And then from there, we get that our area, just in terms of rearranging it, is 1/2 BC sine of A. And there's a couple variations of that. You could do AB sine C. You could do AC sine B. But the goal here is that you would need side angle side. Now the one tricky thing about this is after we did law of cosines where you have side angle sides, this formula has sine in it. So you want to be very careful that you still use cosine for law of cosines and use sine for this formula. Common mistake that I've seen in other times. Okay, so I'm going to do one quick example with this. Where we can really just plug everything right into the formula, and then we'll do an example where we have to find one of the missing pieces first. So find the area of triangle ABC if side A is 2.2 centimeters, side B is 1.3 centimeters, and angle C is equal to 43.2 degrees. Okay, so in this situation, I mean, you can draw the triangle just to kind of see what you have. Not necessary, but sometimes helpful. So you can see you have your side angle side, and you can go right into plugging in, straight in the calculator, all of that information. Now if you don't have the side angle side, then you would need to either use maybe a law of sines or a law of cosines to find the missing information that you would need in order to solve the problem. And this comes out to 0.98 centimeters squared. Now I could go to the calculator to show this. I think if you plug that in, as long as you're in degree mode, you will be in good shape. I'll go to the calculator when we go to do questions where you're going to need to use previous answers to make sure you're showing all your work. All right, so that's the first example, pretty straightforward. You just plug everything in the formula. Next example, we're going to have to find something first. So example 2, find the area of triangle ABC if side A equals 5 centimeters, side B equals 3 centimeters, and angle A equals 37 degrees. Now in this situation, this is SSA, but remember, if you're not sure if you have that, draw your angle in your lower left corner. And then we do have side A, so we know we have law of sines. And that's 5. And the other side that we know is B, so I'm going to put that on top always. Now you don't technically need to check the height for this one, because 5 is greater than 3. So we're going to end up getting one triangle. The opposite side is greater than the other side, which means it will be greater than the height. Therefore, you will get one triangle. If you had 2 triangles, you'd actually have to find 2 different areas for those 2 different triangles. But in this situation, we only have one. All right, so we're going to do sine 37 over 5 equals sine of B over 3. And really, what we need to find here is angle C, because that's the one that's in between. We could end up solving the whole triangle, but we don't need to. So we'll get our information. Now, I do want to use my exact information, so I will go to my calculator for this to remind you of what to do. So 3 sine of 37. Divided by 5. And then we're going to do inverse sine of that answer. Then we'll do 180 minus that, because we're trying to find angle C, minus 37. Now, no matter what calculator you have, you are using the previous answer for all of these steps. So I'm going to go back, record some of this information. We get angle B is about 21.17. Angle C is 121.83. Again, we're going to do, for the area, we're going to do 1/2 the 2 sides that you have with the included angle. So this is the included angle between those 2 sides, which is what you needed. And make sure you use the exact answer. So if you're using an older model of the calculator, then you're doing 1/2 or 0.5 sine, 0.5 times 3 times 5, and then you're going to do sine of, you either can grab it, or if you have the older calculator, you could do second negative sine. And if you do the problem in order, this should not be an issue for figuring that out. So you get 6.37 centimeters squared. Final answer. All right, we do have one more formula that we're going to take a look at. So you will look at that in your next video, where there'll be 2 examples that we will look at with that formula.